In this presentation, we are going to discuss about threshing in OS. So here the contents are threshing, memory mapped files, allocating kernel memory, operating system examples. So in this threshing, if a process does not have enough pages, the page fault rate is very high. Where the page fault to get page, then replace existing frame, but quickly need replaced frame back. This leads to low CPU utilization, operating system thinking that it needed to increase the degree of multi-programming, another process added to the system. So in this threshing, the process is busy swapping page in and out. So the demand paging and threshing. So why does the demand paging work? So locality mode. So process migrate from one locality to another. So localities may overlap. So why does threshing over? Here the limit affects by using local or priority page working set model. So where the working set model is described by the delta symbol. The working set window is a fixed number of page reference. So example 10,000 instructions if you consider. Okay. So the here the WSS, this working set of process PI, is total number of pages referenced in the most recent. Okay, so here the delta too small will not encompass the entire locality. If the delta too large will encompass several localities. If the delta is infinitive will encompass the entire program. So the here the total demand frames is defined. So the working set model, so here the D is greater than of M, it is in threshing. So policy, if D is greater than of M, then suspend or swap out one of the process. So keeping track of the working set is essential. 1. The page fault frequency, more direct approach than WSS. So here establish the acceptable page fault frequency rate and use local replacement policy. If actual rate is too low, process loses frame. If actual rate too high, process gain a frame. Working set and page fault rate are described by the direct relationship between the working set of process and its page fault rate. Working sets change over time, so peak and valleys over time. The allocating kernel memory so treats directly from user memory, often allocated from a free memory pool. Kernel reduced memory for structures of varying size. Some kernel memory needs to be contiguous. Then the body system. So allocate memory from fixed size segment consisting of physical contiguous pages. Memory allocated using power of 2 allocator. So that satisfies request in unit size as power of 2. Request rounded up to the next highest power of 2. So when the smaller allocating needed then is available, current chunk splits into 2 bodies of the next lower power of 2. Continue until appropriate sized chunk available. So in this body systems allocation, so actually the physically contiguous pages is subdivided into 2 parts. So each and finally, so finite values, after getting the finite values it is subdivided to, so they considers that is in 32 kilobytes. So the slab allocator, So alternate strategy, that is in slab, is one or more physically contiguous page. The cache consists of one or more slabs. So single cache for each unique kernel data structures. So each cache filled with objects instances of the data structures. So the when cache created filled with the objects marked as a free, when structure stored objects marked as used. A slab is full of used object. Next object allocated from the empty slab. So this is a slab allocation. So the memory space for the kernel objects 3 kilobytes. A object is cached. Okay. So it is used to find the cache memory after the slab subdivisions that is done in the physical pages. Slab allocations in Linux. So for example, process descriptor is of type struct task struct. So approx 1.7 kilobyte of memory. A new task allocate a new struct from the cache will use existing free struct task struct. So slab can be in 3 possible states: full, empty, partials. Upon the request, slab allocators use a free struct in partial slab. If not, takes one from empty slab. If no empty slab, create a new. So operating systems examples, Windows and the Solaris. So in this Windows formations, it's the basic concepts of clustering and working set maximum in the process, and the work set is maximum for the allocations, and it allocate or assigns a many pages up to its working set as maximum. Then automatic working set timing is also performed. So in the Solaris, maintain a list of free pages to assign faulting process, and lots free, disk free, min free paging is performed by page out process. So it is also maintained the priority paging. So it gives a priority to process code pages. So the descriptions and the expansions of this Solidity to page scanner. Thank you.